I think that's a good idea. All right. Hello, everyone, and welcome to Handmade Hero. I am going to push around some entity code, as I just suggested. Really all I want to do here is I'm just kind of... This is just a giant dead code elimination pass. It just takes a long time because when you do it in little chunks like this, normally, like I said, it'd be something you do over like 2 days where you worked like, something like 12 hours total or 14 hours total or something like that. And you just do it. But 14 hours is like 7 weeks or something, or more, at the weekend, little weekend chunks. So it takes a long time, but that's all we're doing. It's not a big deal. We're basically just getting rid of a bunch of stuff. So anyway, what we were doing here is we basically took and we said, okay, let's streamline how all the entity stuff works now that we know that it doesn't have to do 3D. And we can also keep our world chunk packing and unpacking more straightforward because we can just do it in place. We don't really need a cache. We don't really need to like overcomplicate that stuff. And we don't even really know if we need to be able to look up entities by ID anyway. It could be that we just always spatial query them, and we're done. Now, there is an open question, which is, do we want to do something where we specifically track a couple entities that need to know, where we need to know where they are all the time? That would be, for example, like the player entities, because maybe we need to be able to quickly know where they are so we can like hop the camera between them, or other stuff like that. That's an open question, but what I'm basically figuring is like, okay, so my plan is that I'm just going to do that for the entities where I actually need it. And so if we need a system for looking up entity IDs, it will not look up all entities. So it will not be a generalized entity lookup system. It will look up only those entities that we decide to track. And instead of building the system around that capability, which is how normal entity systems kind of work on that premise. They are by ID, which presumes that the primary thing that you want to do with an entity system is look up by ID. And that is normally the case with the way normal entity systems are written. For this system, it doesn't look like that's very profitable. Spatial seems better. So the idea is to just store everything spatial. And then if we do need an ID lookup system, then what we will do is just track for those entities that we do believe we need it. We will just track those IDs in a separate table that just says where in space they are, and so we can then defer to the spatial lookup for everything. And for the times we need an entity ID lookup, we just look in that table to find out where spatially they are. So it's basically just inverting. It's just like turning things on their head. Instead of being entity ID primal, spatial secondary, we're just doing the opposite. It's spatial primary, entity ID secondary. That's it. Okay, now I think we more or less sketched out all of that, and we even typed in, if I remember correctly, like if you go back and look, we actually wrote like the pack and unpack, so we've got like those things. Where did they go? They were in here somewhere. My memory of what we did is better than my memory of where we did it. So ensure chunk unpacked and ensure chunk is packed. I don't really know if we got these right because we kind of just sketched them out, but, here they are. And so the idea was these two would just allow us to, anytime we were working in a particular region, we would unpack that region, and anytime we move away from a region, we just pack it up. And that would allow us to keep sort of the way our entity system worked under control, in case we needed to start minimizing the storage footprint for entities by, say, not tracking particular pieces of information. Once those pieces of information are not useful anymore, things like, ground cover and stuff, which can be quite sizable, we wanted to not use extra memory for that when something is not actually visible. It's not actually, used on screen, right? So basically, yeah, that's about it. Sorry, I had some stuff up here that I was sketching for before. I was trying to show some things with a multiply add. It's a long story. You'll see. Anyway. So anyway, when we do the rest of this stuff here, we just now need to kind of continue pushing it through. And the spatial lookup stuff we want to kind of continue We want that to persist because as we unpack chunks, we want them to stay spatially coherent, probably, because when we do things like collision detection, we're going to want those things to be spatial. So I think, kind of the broader idea here, too, is that we will just have these, we will keep things in these spatial chunks and just move things from chunks to chunks as they move around so that we can take advantage of that as an optimization as well and not have to have like lots of different stages of that. So looking down at stuff that isn't working right now, so we've got these like world chunk iterator things. And I think we kind of wrote this as okay, we're going to iterate over the chunks. Different pieces of the code will have to do like world queries. And I think we wrote it and then kind of changed a little bit the way this is working. So you can see here we've got this world chunk iterator. And the idea is that you would give it a min and max chunk to loop over. And I think just what happened is we just sort of changed a little bit the way that it worked. And I think that's basically all we need to fix here. I think we still want this. I don't think we want to cut it out. Like, we want to keep it because we only just made it, and I do think this is probably what we want. Don't quote me on that. So what you can see here is we're taking this iterator in here. For some unknown reason, we decided to call this result, which doesn't really make any sense. I assume that's because we did like a copy and pasta from something down here. Obviously, this is the iterator itself that wants to get checked. And all we're doing is saying, all right, this is going to be an x first, y second iterator. So if the y value gets above whatever the maximum is for the bounds that we're iterating, then we assume that we're done iterating. So that's all this is. It's just a way of checking whether you're done. And if you've never seen anything like this before, all this is essentially what we're doing is we're taking two nested for loops for y equals min to max, and then inside that for x equals min to max. All I've done is turned two for loops into one for loop, right? It's just a way of allowing code, code throughout your program to instantiate, if you will, a version of this double for loop that's automated. So it always does it the same way. It's sort of the way in C that you do the equivalent of things like closures or lambdas, right? You want to write an iteration once, but you want to change what gets done inside it. Some other languages, C++ included now because they added lambdas and other nonsense like that, encourage you to do it the other way. They encourage you to basically write the for I loops, and then someone else is going to like inject the code into it by handing you what the inside of the code looks like. This is the opposite of that. This is just saying, look, we'll write the iterator code as something that can be pulled into other pieces of code, and they will write it themselves what they want on the inside, and they'll just reuse our iterator code, right? So it's just which way it pulls. It's fairly straightforward, right? So basically that's what this code is doing, and the reason for that, again, is just for it's just for ease of use, so that I can have to only do this once. So inside here, ensure valid chunk, what you can do here, what you can see here is this is maybe or maybe not a good idea. What this is doing is saying, well, when we do our iteration, we presumably want to skip chunks that don't have anything in them. I don't actually know if that's true. It could be that this is a mistake and we actually don't want that. But the idea behind this code was that we would do a while loop, and we would try to find the first time we got a it's self-explanatory, but we were trying to find the first time we got a chunk that actually has an entity in it. The goal being to automatically skip over chunks that have no entities. This may be pointless, and probably is. it just doesn't seem... My guess is this may have been too overzealous. The reason I say that is because when we actually go look at the code we're probably going to write, I'm just not sure you get any benefit out of that. Each of these will probably have a for I loop over entities inside them. And so this is probably just kind of useless, right? So I'm a little suspicious of this, but either way, let's just finish it up. And then maybe we'll take a look at it in context and decide if we want to just simplify it down to not quite doing that. Because I don't see the point. I'm pretty sure this is stupid. So we'll leave it at that. So inside ensure valid chunk, you can see us trying to call get world chunk internal, which is this. And what get world chunk internal does is it basically just asks for a particular location. It looks to see whether or not there is a chunk there that matches, right? So it's basically a hash line scan to see whether anything in this hash, in this particular line of the hash table actually matches. And so it's just going to keep looking for that, and it's going to stop when it finds one. Why this is unhappy is because these two are passed separately. Now that actually takes a v2, so we can actually delete that breakout, and then it will be fine. We look at iterate chunks here. You can see us creating a rect min max out of the chunks that we have, the min chunk and the max chunk. The reason that this is grumpy is because the world position names got changed. We now just have a chunk. Again, this was because we changed to actually using vectors. So again, this is more convenient now. We can just do a min and a max, which is just nicer anyway. That's all we're really changing there. And I don't know, so there may not be a min-max for V2S's, I guess. This is the horror of sort of piecemeal math functions, but yeah, so we don't have one that takes these. They have to be broken out. So, you know, the math giveth and the math taketh away. We do actually need to put in the dot accessors just because we don't have one that actually takes V2S's for some reason, and that's just, you know, the way of the world. So that's about it. Nothing interesting here. Everything else looks fine. So I think that's all good. Looking at begin world change, we don't care about any of this really. I mean, I'm assuming I saved this function because I just wanted to make sure there was nothing else in it that we needed, but I'm looking at it now, and I don't really see any point to it at all. So yeah. So I don't really see any point to that. There is a sort of separate thing, I guess I would say, which is I don't know if we do want the brain scan, where we pick brains out. Sounds very zombie-like. But that is an operation that we may want to keep. It would still be spatial now, how we pull entities out into the brain set. But I don't know, like, do we want to do that? Do we want to use, like, one of these... one of these things where we gather those. The reason that I'm toying with it in my head is because if you consider what's going to happen, there are two ways that we can have multi-entity systems coordinate their movement. One way is to continue doing what we're doing now, which is before we begin processing a particular frame, we gather up a table of all of the entities with brains that need to be assembled, right? So active entities, basically entities that have AI involved in them. And then we loop over those at some point to process what they want to do. The other way is we don't do that. And as we are processing entities, we gather entities on demand. So when we see an entity with a particular brain type, we do the spatial query for entities nearby that share that brain type, and then we do the dispatch locally. That's cleaner in that it requires less work to do, but it may be less efficient because it means that you may iterate over things spatially more times than you needed to, because you, instead of doing a single pass where you gather everything, you're doing lots of passes. Since it's purely a question of efficiency, though, I want to say that kind of suggests to me I should just write it the simpler way first, where we gather on demand, because otherwise I may just be writing this pre-gather step for no reason if it turns out to not actually be a problem. You know what I'm saying? I have no idea, right? So that's like, that's my argument for deleting this code. And if later I'm like, oh my God, I can't believe I deleted that code, it was critical, you know, that's on me. So let's see. Now we get to a couple things that we need to work on here, which is like tile is open. And this is just asking for a given tile index, you know, whether or not it's just like, can someone be there, right? So there's a couple ways we can do this. One is we can map it to the world chunk. I think that's probably what I'm going to do, where we just like go look in the world chunk and see if anyone occupies the same tile, right? And, you know, we may want a flag filter. So we may want something where we can kind of say like, hey, is this thing open or not? I don't know. Like maybe we would just do like this. And you say, is this tile open? You know, this square of the world. And what we're going to do is get a world chunk from that. So kind of like this thing here, where we get back one of these world chunk iterators, maybe we can just like sit on the back of that, right? But basically what we would be saying is, okay, we want to loop through everything in here and see if the tile is open or not. And maybe this will turn out to be too slow and we need to have things sorted inside here better too. And I don't know. But for the time being, I will just do like world chunk iterator. Iterate chunks for tile index, something like that, where for a given tile index, I can ask for anything that overlaps it. Something like that. Now, inside of here, we would loop over the entities, and this is why I was trying to say before, I was like, well, I feel like each of these things is going to be like, you know, if you look at this sort of thing, we're going to want this. And there's not really a lot of reason to write this more complicated, because either we're going to do this thing that I'm doing right now, right? Which we could do. Or we're going to want to write it the other way around, where we literally do just that. One or the other. And so my guess is that we don't... That's why I was kind of saying, like, if anyone's going to do the, like, skipping empties, it feels like it will be the entity iterator side. Right? I mean, probably... I don't know. So my guess is that we want something that looks like this. And it probably looks actually specifically like this. Right? So we're going to say, like, we want to iterate all the entities. And so we'd say iterate chunks for tile index. We'd pass the world in the tile index. And then we'd say iterate entities in this thing. This is probably... I don't really know about this world region idea. You know, I don't know why we don't just use the iterate chunks part of things, but I don't know, maybe we don't. But anyway, it would look something like this. So maybe we do that. And so maybe our world region in this case is just like the 0 radius or something. Yeah, I don't know. I'm going to defer, and I'm just going to say, like, get region for tile index, and I'm going to give the world in the tile index, right? I'm just going to say, like, this will work out somehow. And so for each of these, I'm just going to look at the entity, and I'm going to ask, like, for that entity, excuse me, like, there's going to have to be a pointer, and maybe I should do more like ent iter here, right? Just so I can then do like entity equals ent iter, like pointer or something like that. So we'd get, like, we'd actually get the actual entity out of it or something like that. Doesn't matter. But point being, all I want to be able to do is ask for a particular entity. I want to know if it's on that tile index or not, right? And if we look at the actual entity encoding, so, you know, the idea here was that we'd actually be storing that with an offset from it. And, you know, again, I don't know that we'll persist that, but if we are going to persist that, then we can literally just do an r equals. So, like, here the tile is open. This should probably default to true, because the tile will normally be open until we find someone on it. And so we would say, if we found someone on it, then the result is false. It's not open anymore. So we do an r equal of the tile index with the tile index that we're actually querying. And that's the entirety of the of the routine. Now, of course, we have to actually write this thing because we don't actually have it yet. So that's a thing, but otherwise, whatever. These now don't take sim regions, they just take worlds, because they don't really need to know anything about what you're doing at the time. They should just be fine. And, like, do we really need to unpack everything or not into a spatial grid? I don't know. My sort of, like, vague hope here is that we just get away with it, so we can just keep it this way, right? I would say, like, if we're lucky. Just keep it this way. So that will be good. Transactional occupy is just the same thing. Nothing particularly interesting there. Here, I guess we would... So the overlapping entities exist thing, I don't really remember what exactly what we were using this for, but my assumption is this is mostly just for collision detection, but let me just check. Either way, again, that can remove the sim region because you should be able to ask if overlapping entities exist without needing that. Right. So the main problem I see there, I'd like to see where that's called. Okay, so this is in the generate apron call, which is the thing that goes around and like places it just places like trees and stuff outside of the orphanage and stuff like that. So this doesn't really need to happen this way anymore. We could just query tile indexes directly. So we really don't need this. In fact, this is worse because, yeah, like this can just be simplified. So I'm going to go ahead and say we want to delete that. So the question here is, tile is open. Also, you know, we probably just want to like beef that up a little bit because there's two things you could mean when you say tile is open. And we really probably want the ability to query a more fully stateful thing there. Like we want more information because we want to know two things. We want, with one call, it's going to do the work either way. We might as well find out, is this a tile that you could stand on? And is there anything there? And those are two different questions because, like, you can have something on a tile, like a tree, but you can't stand there. And you might be asking, like, different questions. So I kind of want that. This needs to be better than it is. That's what I think. So I'm going to get rid of this, and we're going to do this in a slightly different way. And I think that's how we're going to do it, right? Yeah. Okay. What was using get closest empty tile to? So these are like for placing things in the world. And they would still work pretty much as written, right? I don't know that we want to be using these, but they would work just fine. So yeah, we should be able to keep all of those going. But anyway, so when we do like tile is open, the way that I'm thinking of it is like if you look at like the flags on entities, we've got like this sort of stuff. And so what I'm wondering is like we want to be able to like talk about, can you stand somewhere, can you not stand somewhere, and things like that. And so I feel like that's really the information that we need here. we could just return, like, we could OR all of these flags together. And just return that. Which maybe is good enough. And then we just add one, like, you know, there's like entity flag. So basically you could just say like this thing allows, like, supports someone like occupying the square. So like if you get back a supports occupation but no like occupies tile, right? If flag 6 is set but flag 4 isn't, then the thing is open to be occupied. Something like that. How do we feel about that? Maybe that's too clever and it's like not really gonna work. But if you imagine this being something like get tile, you know, or tile flags, or all flags on tile, or something like that. And you go through here and you say, okay, there's a result. And the result starts out as 0. We go through all the entities that are on the tile. We look to see whether or not you're on this particular entity is literally on the tile or not. And if it is, then we OR in those flags. That's kind of interesting because then we could say, like, is the tile occupied? And we could say it's a little bit ambiguous because, you know, does that mean if there's no one on the tile but it's not a tile that could be occupied in the first place, would you call it occupied? So that's a little bit weird. So I might look, who is asking that question and can we rephrase it to be clearer about what we mean? So it's literally only this one. So I would say that really needs, I would say tile is occupied is a bad phrase. It should probably be can be occupied. Because tile can be occupied would be like clearer, and we could say, all right, a tile can be occupied if we get the flags for that tile, and the flags both have and don't have some things, right? If the flag has supports occupation, but the tile does not have occupies tile, off we go, right? So if it supports occupation but isn't occupied, that's what we need. That seems good to me, right? So here we would say like transactional occupy. This would be an if tile can be occupied, right, as well. Because if the tile can't be occupied, then you can't execute a transactional occupy. So I think that's just better. And then this piece of code over here is a you know, tile can be occupied. So since this is a not equals to, I don't know, we could just change the sense of it, right? Like, but it's fine. Let's leave it as is. That all looks fine. So I think this is all just totally fine. This part, get closest entity with brain. I don't actually know what we use it for, but I think we use it for like, what do we use it for? Probably chasing the player. Yeah. So if you imagine that we wanted to do something like this, which seems plausible, this one is also pretty easy now. We would just say, okay, we do the same search as we were doing before, this one right here, and we iterate over the entities that match this particular region. The only problem we have is this has to be an actual world position. So it's something like this. And this has to be a world position. Oops. Then I think we're good. Everything else should be fine. Now, the delta is just going to be like that. And I think that's it. Yeah. What is it complaining about? Oh, this test entity position. Right. So, accents, you're absolutely right, by the way, about that. Sorry for those of you who do not have the chat up right now. They brought up a good point, which is that they used the wrong and. Of course, that should be and, because these won't line up, right? This bit and this bit are in different places. So when I and these two together, so there is a different thing I could do, right? So this not will turn this one into, it will actually be in the low bit, but this one won't be. So, you know, I would have to do something like this where I shift it down to line it up. So using this and is just better because that way I'm just doing a Boolean and of the two, so I don't have to care about what bit position they're in, if that makes sense. The hashtag embed gang sends their regards. What is the hashtag embed gang? Or is that the poor souls who tried to get the C++ standards committee to actually make like a straightforward way to embed data into code and was just like put through the ringer for that seemingly very simple, very reasonable request? If so, my heart goes out to you. I literally want that tag all the time, and I remember seeing the person who requested it and how they were treated by the C++ committee, and I was horrified. It was such a simple, straightforward, obviously useful thing to ask for that I myself had wanted on many occasions and don't have. And the absolute nonsense that ensued after that was a good example of why C++ is a lousy language, because that's probably the last time that person's going to want to make a reasonable suggestion, because Jesus. It was so much work for them to just get this simple thing done. It was just brutal. Just absolutely brutal. I mean, it should have taken 10 seconds. It should have been like, yes, right, good. Yep, we've got it in there. Anyway. So anyway, yeah. So I think we want to just stick with this. And the only problem that I think we're going to have here, like I said, is how do we want to actually encode these world positions now? So there's a number of ways we could do this. One is you can just put the world position directly in here, but another is that they're encoded relative to the tile. I really don't know. My assumption is that probably what you want to do is you want to just like there are many ways we could choose to do this, and I don't know which one of them is the most efficient. One way is that everyone stores their integer tile index and then the v3 offset off of the tile. That is just these, right? The other way we could do it instead is we could store the everybody is relative to their chunk, and the chunk is aligned to tiles. I don't know. Agastev, have you removed the math library? I don't think we ever did cosine. We probably just should. We did replace square root, obviously, because you don't really have to do anything. Replacing square root is like that is the code for square root, right? The chip does it for you. So square root is like really easy to replace because you don't have to actually do any work. We did not replace sine and cosine. I think those are the only two we didn't replace. Those are really easy too, but it takes a while to explain what you're doing. So atan2 I think we eliminated. Did we not? It's still used in the debug code, unfortunately, but only in the debug code. So I don't know. We'll probably want to like fix that because we're probably not going to want to. atan2 is a pretty big function. So yeah, but sine and cosine you have to just go. You have to actually go do the math to solve for the coefficients that you're going to use for your approximation, right? So what you're going to see if you want to do that, if that's what you're doing right now, is you're just going to want to take this angle here, and you're going to multiply it by a series of coefficients, and then you're going to return the result. But it takes a while to go find to actually do the math to solve those. Mathematica will do the Pade coefficients for you, so you could just literally type that in, but those are used with a divide. So so if you do yeah. So if you do like, if you want Pade approximation, you can just get them. It will give you exactly what the coefficients are. You can see them here in any number of forms. So that's fine, and you can ask for what order you want, right? I don't know if it will do Chebyshev for you. So I don't know if you might be able to cheese out and get this to do like minimax and stuff for you. I don't know. I'm sure I'm not spelling that correctly. But yeah, I don't know. I've never tried to do that. I knew you could. I remember I could get it to do Pade automatically. I remember doing that once. I don't know if you get to do Chebyshev for you, but anyway, there's various different kinds of functional approximation formulas where you solve for the coefficients that you're going to use to approximate a function around a specific point. You need to go solve those, and you're probably going to want to solve them with a numerical package because I don't know why you would ever solve them yourself, although you could. And then your function just looks like a series of fmads, right? It's like fmad, 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 return, right? There's typically a little bit of fudging that happens right at the top, which is like, look at the range of what the angle is in, because since sine is a symmetric function, you typically use like 4 ways symmetry or something, and you only approximate part of the curve because you know that like you can mirror the rest of it or whatever. So that happens at the top for transcendentals, and then you just approximate it. That's all it is, but it takes a while. And I don't know if there's a tool to do it for you easily. There might be, but I don't know. Like I say, for Pade coefficients, you literally just type them into Wolfram Alpha, it does it for you. And there's probably one for Chebyshev as well. I don't know how to get Wolfram Alpha to do that easily. But I'm sure it would be weird if you couldn't. So I'm sure that stuff does exist. I just don't really know about it because I don't do it very often. Those divides will bite you. I don't know what that means. What does "but those divides will bite you" mean? I don't know what that means. Okay. So yeah, so the main question that I have here is like, forget close affinity with brain. It's that I'm not sure where we're going to get this p-value from. So that's... The divides in the Pade are slow. Well, there's only one divide, and it's not slow. I mean, you can do a reciprocal of it if you want. Right? It's not that bad. I wouldn't necessarily recommend it because I'm not sure why you would bother, but there's only one divide. There are not multiple divides in a Pade approximate. It's just like one polynomial over another polynomial. So you compute the two polynomials, you do one divide, and you're done. Right? And like, you can use fast reciprocal if you want, but like the reason that you probably don't use Pade approximates is because if you're going to use fast reciprocal, then you're probably losing the precision you were going to get from a Pade coefficient in the first place. So it's probably not very useful, right? But it's not that bad. It's just only one divide. And divides are like, what, 6 cycles now? What's a divide these days? I mean, it's throughput 1, so you can do them every cycle. Well, I guess it's technically 3, right? It's would be 1 if the port was free the next cycle, but it's not. So it's 3. It's every 3 cycles. And I guess it's what, 11, 18 cycles. I guess that's from memory. So 12 cycles. It's not that bad. What does Zen say? So 11 cycles is not that bad. But again, it's not great, right? Is the point. Like, if it got you like way more accuracy because you did the divide, then you'd probably start thinking about it because it's not that expensive. And also, like, if you want to do reciprocal, right, that's really fast. That's a 4-cycle latency instruction. So, you know, but the problem is I don't think you really get anything from that. Like, Pade coefficients aren't like way more accurate or something than Chebyshev for the same amount of math. So I think it's still true that you probably don't want to use the Pade coefficients anyway, because it's not going to be, if you had just done more multiplies, you probably still come out ahead, because you're going to cost you roughly between 2 and 3 more FMADs to do it, to compared to the divide or whatever. So probably, but I don't know. I've never compared them. Maybe you should use Pade coefficients. I don't know. Somebody else who is into math function approximations should look that up. Anyway, all I was trying to say is that in 10 seconds, you can go to Wolfram Alpha, type Pade coefficients for cosine, get them out, cut and paste them into your code, and you now have a replacement for cosine, right? The only thing you have to do is the range reduction, so you map it to just one arc of the cosine, of the sine or cosine, but that's it, right? So it's trivial to replace sine and cosine sloppily. If you want to be better than that, which you probably do, then you need to do some more work, right? And like, choose how aggressive you want to be. So I don't know about this. I guess what I would say is I probably want to just kind of like abstract this part a little bit, not for the sake of abstracting it in practice, but rather to delay me making a decision about it for a little bit longer. So what I might say is, in the places where we're looking at the tile index, maybe I want to do like get tile index of or something. And here I want to do get world position of. And the reason I'm doing that is just because I don't know which one of these I want, right? So get world position of test entity. And I don't know why subtract is taking like pointers, because these aren't like large, right? They're like 5 values, and it doesn't really feel like pointers to them are warranted. So yeah, I don't know about that. So when we're iterating over these guys, like, I'm just thinking that there's a fair bit you could do here. Like, the entitor knows which chunk you're on, which means that you wouldn't have to store that identity. It could just kind of like come from the thing. You could say get world position and you could do that by saying like, oh, I'm going to pass the entity iterator and get the world position that way. And that's kind of interesting because it means that wouldn't have to be entirely stored in there. So I don't know. I'm just going to kind of sketch those out that way and pretend that works. And then we'll look at it next week or something when I want to actually tackle that problem. So now we get to like find random open tile and get closest empty tile too. And I think, mostly the problem here is just the fact that we got rid of the sort of grid thing, so we don't know how big of a region we're looking in, is about the only problem. Because otherwise, really, we already have this ability to do this query now. So I think it should just be fine. So I'd like to just go make sure I know who is calling these and why, but otherwise it should be fine. And excuse me. Yeah, so I think that's really it. I don't know that there's I don't think there's much else there to worry about. So I'm gonna push this up to the part of the code that's actually in the H file, just so we can see more clearly what all the different ways we return stuff is. But so I think that's all good. These are not happening anymore. So this is just not a thing. These go away. And we're going to replace those with the spatial iterations pretty much always. I don't know if I want to do these guys yet. Maybe I do, maybe I don't. Tile result is not a thing anymore. So I need some context here. Who calls this and what are they doing and what do they have available? Okay. So get closest empty tile to is just a function that attempts to find a place to put a player when a player joins the game. The tile result is just a way of combining those two things. So add player. What a strange way we did this. But yeah, okay. So essentially what we're saying here is, yeah, we're gonna pass the world here. We don't need a sim region, but we do need a world. I'm not really sure that the world mode should have been passed into this. That's a bit much. But that's sort of a separate issue, I guess. Okay, so we won't worry about that right now, but and game mode world presumably has the world pointer as well at the top of it, so that's kind of a separate issue. But so it means we really don't need any of that, and we can now just do world mode world. I'm not so certain that it should take the world mode because it seems a bit extraneous. So I kind of feel like really that should probably go away. And what should actually happen here is that we'll just return whatever the entity is that you're supposed to nominally be following. We'll just return that entity. So if we we're gonna follow the body, which was here. So body ID, we will just return that ID, like so. And so in here, we'll just say okay, whatever the thing is that came back, that'll be what's shoved into the the thing the camera is looking at. And that keeps that more, sensible, I think. Now, placing this crap in the world, I mean, it seems like that's all fine, I guess. I don't really have a problem with that. That all seems fine. So we'll leave it that way. When we do this get closest empty tile to, the problem here, the reason we had this tile result was just because there was sort of this notion that when you find something, you have to determine whether or not you actually found it or not. So we had this sort of tile result that was just a bundle of was it valid and what was the index. Now, that does seem like, I don't know, could we simplify that at all? Like, do we really need something just for that? And like, maybe the answer is yes. If it is, then, you know, it stays. So I'm not sure. That's a good question. But anyway, we can defer those, oops, probably a little bit. But honestly, sort of like I said, you know, I don't know. It probably actually just kind of works. So if we imagine that we do decide we need to implement this function, when we go through here, like what's the actual limiting factor, we're going to say like get direction. We're going to check a tile like in that direction and see if it's open. Right? And so this is a little bit dumb because, you know, now we don't really have we don't go up and down anymore. So it's kind of like seems like a bit overkill to be doing it this way. But I assume we still have the get direction function in here somewhere. Do we? Yeah, we do. So we still have get direction, and that returns a V2S. And the tile that we're going to check is just the base tile. And so, like, it's just this, right? And so the question that I have, of course, is just that I'm not sure when we say find adjacent open tile, it's really just a nomenclature issue. What does that mean? When we say find adjacent open tile, do we mean a tile on which somebody could be standing, or just something where we didn't put anything yet? And that's why, like, it's, you know, we probably should try to make up a terminology here that's going to be consistent so that we don't confuse ourselves, or that I don't confuse myself about what we're asking for. Because we can answer both of those questions, but I don't know which one we were actually asking. So if you look here, like, it looks like basically we're saying something that could be stood upon, right? So we're sort of saying something that is tile can be occupied, right? That's what we're really asking. Now, get direction is no longer in the mix, I guess. Because why? Because we got rid of the box stuff, maybe? Because it's that. And I guess the idea was we were just saying, like, look, we probably want to be able to get this directional thing, but, like, maybe we don't want to have to keep including this code, was the idea. So, I can get on board with trying to get rid of that. Because that's the only place we use it. That seems dumb. But it does seem like we are still including it, right? Like, so it was just that it happens to be in the math library is the only reason for that. Which, why is it in there? Does someone want to explain that? Because I don't know why it would be in there. If instead we just put it in here, doesn't that solve the problem? So I don't really understand what's going on there. I'm not sure I want to know. But anyway, so that should be fine. And then the result.index and the result.valid, that should just be that, right? So the tile result, it shouldn't be tile, it should be index. So that is how that function would work. I find random open tile, again, not sure, but I'm assuming that it means open as in can be stood on, but let's find out. So yeah, like it looks like it's like putting a thing on a tile where someone could stand. So my assumption is here, really what we're asking is for some like range, which I think the problem that we have here is we need to define how wide we are looking. And I don't know if when we did this like pattern gen stuff, if we really, specified that. But find random open tile probably needs to be something where we take some bounds, right? And before we sort of had the grid for that, but we don't really need that anymore. So we just need something simpler, like just here's some boundaries. Like here's some idea of the range we're going to find. I don't really think we're going to use this that much, to be completely honest with you. Because I feel like the generator, now that we're sort of the new stuff we were doing, is probably not going to make a lot of use of this. So I don't know we should really kill ourselves in trying to make that work. So I don't know. Maybe we'll just like if zero that for now. Quietly. And we'll revisit it later. All right, so we have to write that entity iterator because we didn't actually write it, and that'll have to happen. For the brain stuff, now we have the question of how, first of all, should I stop here? What time? How long have we been going? Where is the stream timer? 2 hours. What time? What is the absolute time? 4 o'clock. Yeah, I should probably end. My voice is getting tired. I had to record a podcast this morning as well, so maybe I'll wind it down. Okay, so let's do brains. We'll do brains next weekend. But yeah, I mean, basically just a lot of typing. You can see how it works now. Like, there's nothing. We're just removing two things that used to be there, and we're just getting rid of them. That's all we're doing. And so all we really need to do is just finish that. Not much to talk about. Very straightforward. So what we need to do next time for brain stuff is just make it so that they will gather, we'll have the brain be called directly out of the entity code. And it will gather things that were next to it, like look in its immediate vicinity for things that are attached to it that are supposed to be simulated together. And that's it. That's all it'll do. All right. that's it. I'll see you next week for that. Until then, I'm hoping maybe John Blow will stream this week. I haven't seen a John Blow stream in forever. I'm sure he's probably not streaming right now. But I will check after. So anyway, thanks for joining me. I will see everyone next week. And until then, have fun programming, everybody.